Hi, welcome to the KubeCon EU and CloudNativeCon 2020. So let's get started. So the title of this session is Service Mesh and Serverless Chatbot with Linkerd, K8s and OpenFaas. I am Sergio Méndez. About me, I am an operating system professor and entrepreneur. I have a project called Cloud Society. So it's about joining open source communities and that kind of things. So I am a cloud native enthusiast. I am working as a SRE at Wiseline. I am a meetup organizer of a Cloud Native Plus GT, and it's really awesome to share cloud native technologies with the people. So let's get started. The IT infrastructure and evolution. So there are several steps in the evolution of the technologies, or maybe the different steps that you are using to deploy your application. So for example, maybe you are deploying an application in a monolithic architecture, so you suppose that you are using a host, so you are close to the bare metal and you are installing like a kind of hypervisor, and you are deploying your application in a virtual machine. So maybe you have some control in talking about of the operating system. So maybe you are using containers, so that containers doesn't use a hypervisor that is associated with that kind of virtualization in the bare metal. So maybe you are packaging or the logic of your application inside a container, so you have less control in difference with a monolithic architecture, because you are maybe deploying your application inside the container, or you are only have that control in the container. So in the serverless, you don't have control about the host. You only deploying a small part of code and that's it. So there's no server there. So in the basic concepts, first the cloud native. So cloud native is taking approach to building applications using that cloud computing model. So you are paying for that services in the cloud. So in a second concept about cloud native, so in that cloud computing model, you are using containers, maybe microservices or service meshes, and taking advantage of that cloud computing model. So that's essentially the cloud native thing, and I can mention the cloud native apps that uses the 12 factor to build their application. So serverless, well, you are taking an approach of software solution that you are deploying only the small part of the function that you are running in some transient servers, so you are paying what you use in that moment. So in that environment could be very elastic, so you don't have to operate or to pay attention to the servers, but because of the concept that don't have servers. So serverless has a high level abstraction of the service, so you only deploy that small part of the code, so you don't have to worry about the servers anymore. So that's the really cool thing about serverless. So serverless provides you some features, for example, the event-driven thing. So the serverless start when you are receiving some request in the platform. So when you are receiving that request, the service turn off, and after a few minutes, that service dies. So only lives during the time of the request. So it provides you some kind of streaming data and auto-scaling kind of service and fault tolerance. So the good things and the bad things are the good things are cheaper. It's cheaper than traditional cloud services. It's scalable. You reduce the ops cost. You are focusing more in the user experience and depth. So in the bads, there's a vendor locking thing, because you have to adapt your logic or your software to the serverless service that your cloud provider gives you. So there is a learning curve to understand how your cloud provider implement serverless. There's not suitable for long-term tasks, because that serverless functions only lives for a short time. So depending on your provider, maybe don't support the language that you want to create your serverless function. So about controlling the system, you don't have more control, or well, you have less control on that infrastructure. So you don't have access to the servers or that kind of thing. So you are only deploying your code in that platform. So you can use serverless in the in Internet of Things, so to create chatbots, assistants, or for APIs, some kind of streaming, so implement service for image manipulation, or event processing, or multi-language applications, or to implement some kind of CI/CD, depending on the case. So what is Service Mesh? So Service Mesh essentially is like a kind of service that lives in the service area. So lives like a side container of a sidecar together with your service. So this sidecar, when you're looking here, this your primary application and the sidecar. So the sidecar receives all the traffic as a proxy. So that sidecars perform as a proxy. So the sidecar receive all the traffic and decide what to do with that traffic to forward to the original application or drop the traffic. So in this graph, you can see, for example, in the Kubernetes context, a pod could have more than one container. So one container is the service mesh that receives the traffic and forward to the original microservice. So the service mesh has two components, the data plane and the control plane. So it's really awesome. So in the data plane is living your application. So the green square could represent your original container, and the blue square could represent the sidecar or the proxy element of the sidecar that receives the traffic. So when they receive the traffic, forward or ask to the control plane what to do with that traffic, or generates metrics and apply some policy and show that information in the UI. So Linkerd is an ultralight service mesh, so it's really easy to use and to implement in Kubernetes. So gives you that kind of observability or reliability, or implement that security between your different microservices without code change. So this is really awesome. So has the same architecture, though, when we are talking to the basic concept of the implementation of service mesh. So has some control plane and data plane. So has different components, for example, implement a tab identity, or maybe some validators use an API, so you can access that API with the CLI. Has some web panel to show the graphics, or maybe is recording some metrics in Prometheus and showing the graphs using Grafana. And in the data plane is your original application with that Linkerd proxy or the sidecar that receives the traffic and that throws to the control plane to decide what to do with that traffic. So what Linkerd does? So Linkerd gives you that observability and reliability and security thing. So with the observability gives you that power to generate golden metrics like success rates, latency, throughput, and show you in the panel that service dependencies or topologies to implement that kind of timeouts or circuit breaking when you are traffic splitting or that kind of things, to implement security and secure the communication between your containers using TLS and that kind of thing. So why should I care about who can use service meshes? Could be used by SREs and architects, because they implement observability and some security primitives, because they are very critical to cloud native applications or architectures. And the funny part is that you don't have to modify your application to get that benefit. So that's the really cool thing about Linkerd. So OpenFaas is an open source serverless platform. I can mention about OpenFaas is that gives you that platform to implement service mesh in a to create event-driven functions. So these functions are created as microservices packages with Docker and deploying to Kubernetes, but there are different versions in how you can deploy OpenFaas. For example, there is a version that you don't use Kubernetes, only containerd. There's another version that you can deploy OpenFaas using AWS Fargate, and OpenFaas provides you that auto scaling and metrics for your serverless function without limits of execution like lambdas on that kind of thing. So the features are the OpenFaas provides you that easy UI portal to package your functions, to provide you portability to move your functions, provide you a CLI to manage that functions, and some jobs for configure some options in your functions, and provide you that auto scaling from 0 to like lambda, or it depends how you configure your function. So there is a reference architecture about OpenFaas. So OpenFaas internally uses a lot of software there. For example, NATS to create some queues, Prometheus to recollect some metrics to show in through Grafana and different components. So it's really awesome. So in a serverless real use case scenario, I can mention that in my past job in a telco company, we were creating chatbot tool. So this tool was the mission of this tool was to create custom chatbots, and they are executing using Slack, Telegram, WhatsApp, or Facebook. So right now I am trying to implement some observability and some canary deployments to that chatbot. So this telco company and the requirements of their application is to prevent the brand locking. So they agreed to use open source technologies to implement some fast integration about these technologies, the short time of development time, to implement DevOps and CI/CD, to spend less money in a smart way. It could be the performance, the resilience system, and observability. So this software like Linkerd and OpenFaas provide these things. So essentially, the solution has OpenFaas, that serverless open source platform, Linkerd as a service mesh to implement observability and the canary or blue-green deployments, and Kubernetes to orchestrate the different containers created by OpenFaas and scale and provide that scaling thing in the system. So about this is like a kind of execution diagram on how the chatbot works. So I can mention the artificial intelligence theory about agents. So when we are talking about agents, the agent interacts with an environment, so has some perceptions of the environment captured by that sensors, and this agent decide what to do with that perceptions to action to the environment. So uh, it does that actions with the vectors. So the things that provides that perception in the environment are the instant messengers, all the chats, all the texts, and that kind of things that receive the agent in the form as a container deploying in Kubernetes, deploying using OpenFaas, and Linkerd recollect some metrics and do that traffic splitting for the application. So is really awesome in that way. So to be in context, canary and blue-green deployment. So the blue-green deployment, you are deploying basically two versions at the same time. So you are splitting the traffic between version A and the version B. And the canary deployment, you are gradually shifting traffic between a version A and B for some service. So in the architecture of the demo, so I'm gonna implement blue green deployment of canary deployment with 50 and 50% of the traffic for each service. So to implement this, you have to use a dummy function called root. So in this demo I call it chatbot root, and the chatbot green and the chatbot blue, but it's the same logic. Um, The benefits of this solution is that this zero vendor lock-in. There is a fast integration with technologies. You are using technology that gives you that ability to provide a CI/CD platform, and you are spending less money in a smart way and creating an auto-scaling application using open source. So you don't expect some vendor lock-in. It's very silent, and you implement observability without modifying your application. So the demo shows Claudia, a Slack chatbot that is living in my Slack meetup. So I'm gonna show you the templates of OpenFaas to create functions, some integrations and functionality of Linkerd, some canary deployments of blue-green deployments to show you how Linkerd works and the observability thing of Linkerd. So here is a repository that I'm gonna deploy this demo. So if you want to check it, so it's really awesome. So let's start with the demo. So in this part, I can show you the Linkerd dashboard. I suppose that I have configured the kubectl to connect to the cluster. So now here is the Linkerd dashboard. It's really cool. So in this namespace of Kubernetes, the OpenFaas event is publish all my functions. So you can expect to find the chatbot green, like I say, the blue green, and the chatbot root, that is the dummy service. This blue and green service called the microservice every time when I write kubectl in the chatbot, so called the microservices, and I am doing a traffic splitting between these services. So let's write in the chatbot. So for example, kubectl this kubectl again. This is kubectl or maybe hi. So maybe you are seeing like there is passing the traffic like more or less 50 and 50. This is the blue chatbot and the green chatbot, and this is the idea of the container that is executing this logic. So there is alternating the request between 50 and 50. So let's generate more traffic that calls my microservice service. So let's reload this part of the panel so I can show you the dependency of the different service. So chatbot green calls microservice every time that I write kubectl, and the blue does the same. So I can show you the traffic split for this thing. So in real time, I'm gonna try to show you if they change. For example, hi or hello or kubectl, there's changing in that time. So it's really awesome. It's changing. So hi, yeah. So it's changing in real time. So let me show you another thing. For example, this blue is calling microservice. So the blue calls microservice. Let me try. So kubectl. So kubectl again. So maybe kubectl. Yeah, this right now is changing. So kubectl. So let me again kubectl. So in the same time, well, delays a little bit to show the change in the graphics. So here you can see all the requests almost in real time or in real time, how it's deploying the different things. So I want to show you the Grafana dashboard. So here's the Grafana dashboard, and shows you some information about the different microservices and the information that is recollecting. So it's pretty awesome. So here is the OpenFaas portal. So in this portal, well, talking about OpenFaas, I can see my different serverless functions and the URL to access that function. For example, here's an example or function that returns the information of the host, and it's really nice. They are counting how many times you are requesting this function. You can deploy new functions here. You can also delete the function and that kind of things. I want to show you more or less the code of, well, let me access to this server here to show you more or less the structure of this function. So here's the demo. Let me check this. So in this directory, I can show you the different parts of this. For example, in the stack, there is the gateway that we are accessing. This portal is the gateway. So the image that we are using, the image that we are publishing in the Docker Hub. So let's see the different templates. So for example, well, here is the Python 3 Flask template. So essentially gives you a Docker file that you can modify a template, and in the index function with example of how to execute that logic. So essentially it's a container that is executed like a serverless function. So it's really awesome. And to finalize, here's a repository. It's not the final repository. The final repository is the URL that I'm showing in the presentation. So here the OpenFaas has some CLI. For example, here you download the template and you are creating the project to create your serverless functions. In this part, you are deploying your serverless function with the fast CLI. So here's the chatbot green, blue, and root. Here you can see that we are injecting the sidecar to the original function. So essentially, you are getting the jam of that deployment, that you are adding some code to inject another container as a sidecar. So essentially, the service is already deployed and inserted with a sidecar inside. So to implement the traffic splitting is very easy. Like this, for example, this file. You can see that they match this service, and you can describe how many traffic goes through every service, for example 50 and 50, and that's the way that is very easy to implement the open source serverless functions and some observability using Linkerd and OpenFaas. So that's it, that's the demo. So just to continue, well, I have some references that you can visit on the repo. So you can follow me in the social networks with Sergio ERMGPL. You can find me on LinkedIn, Twitter, and that kind of social networks. And thanks. So I think that we passed to the questions, and thank you very much. Thanks.